So let's talk a little bit about the basics of Hadoop, where it came from, what it's for, what it's all about. Let's dive in. All right, let's dive right in and talk about the Hadoop ecosystem. The mascot of Hadoop is this yellow elephant here, and we'll talk about why in a minute. Again, my name is Frank Kane, and I'll be your instructor as we make sense of this wild world of Hadoop. What's Hadoop all about? So what is Hadoop anyway? Well, the definition from Hortonworks, which is one of the major vendors of Hadoop platforms, is an open source software platform for distributed storage and distributed processing of very large datasets on computer clusters built from commodity hardware. Wow, that's a mouthful. Let's break that down a little bit. So, an open source, that means it's free, that's a good thing. Software platform is just a bunch of software that runs on a cluster of computers. So as opposed to just running on a single PC, Hadoop is meant to be run on an entire cluster of PCs that run inside a rack in some data center somewhere. So it leverages the power of multiple PCs, multiple computers to actually handle big data. For distributed storage. So distributed storage is one of the main things that Hadoop provides. The idea is that you don't want to be limited by a single hard drive. If you're dealing with big data, you might be getting terabytes of information every day or even more. Where are you going to put all that? Well, the nice thing about distributed storage is that you can just keep on adding more and more computers to your cluster, and their hard drives will just become part of your data storage for your data. And what Hadoop gives you is a way of viewing all of the data distributed across all of the hard drives in your cluster as one single file system. And not only that, it's also very redundant. So if one of those computers happens to burst into flames in your data set and melts into this gooey puddle of silicon, Hadoop can handle that because it's going to keep backup copies of all your data on other places in your cluster, and it can automatically recover and make that data very resilient and very reliable. The other thing it gives you is distributed processing. So not only can it store vast amounts of data across an entire cluster of computers, it can distribute the processing of that data as well. So whether you need to transform all that data into some other format or to some other system or aggregate that data in some way, Hadoop provides the means for actually doing that all in a parallel manner. So it can actually set all the CPU cores on your entire cluster chugging away on that problem in parallel. And that way it can actually get through all that data in a very quickly. So, you don't have to sit there with a single CPU chugging away on a petabyte of information. It can divide and conquer that problem across all the PCs in a cluster. And of course, it's meant for very large data sets that can't be managed by a single PC on computer clusters built from commodity hardware. And by commodity hardware, we don't mean cheap, we just mean readily available. Stuff you can rent from, say, Amazon Web Services or Google or any of the other vendors out there that sell cloud services. So you can just rent off-the-shelf hardware, throw it into a Hadoop cluster, and go for it. Just go and keep on adding as many computers as you need to handle the amount of data you have. What's the history of Hadoop? Talk about that briefly. So Hadoop wasn't the first solution to this problem. Quite honestly, Google is the grandfather of all this stuff. So back in 2003 and 2004, Google published a couple of papers. One was about the Google File System, GFS, and that was basically the foundation of the ideas behind how Hadoop does its distributed storage. So GFS kind of informed what Hadoop's storage system turned into. MapReduce is also Hadoop's, it is Hadoop's solution for distributed storage of information. So GFS is basically what inspired Hadoop's distributed data storage, and MapReduce is what inspired Hadoop's distributed processing. And in fact, they didn't even bother changing the name. It's still called MapReduce. So Hadoop was developed originally by Yahoo. They were building something called Nutch, which was an open source web search engine at the time. They saw these papers published by Google and said, "Hey, Google, thanks for telling us all your trade secrets. We'll take that from you. Thank you very much." And primarily, a couple of guys, Doug Cutting and Tom White, in 2006, started putting Hadoop together. And of course, they had a bigger team than that, but they're the guys who take the credit. Story goes that Hadoop was actually the name of Doug Cutting's kid's toy elephant, and apparently this is the actual yellow stuffed elephant named Hadoop that the project was named after. So now you know why Hadoop's mascot is a yellow elephant. It's actually named after this stuffed elephant here. And Hadoop doesn't really mean anything, and unfortunately you're going to find that a lot of the technologies in Hadoop don't really mean anything, and it can be hard to keep track of what does what. But that's why we're here. We're going to help you through all that. And hey, the rest is history, as they say. Ever since 2006, Hadoop's continued to evolve. And not only has Hadoop evolved, but the ecosystem surrounding Hadoop has continued to grow. And more applications and systems surrounding Hadoop have come out. And we're going to talk about that shortly. Why Hadoop? Let's talk about that again. So again, data is just too darn big these days. I mean, maybe you have, I don't know, DNA information, sensor information, web logs, trading information from the stock market. Who knows? Whatever it is, in this day and age and the size of the companies that we have today, one PC isn't going to cut it anymore, right? So you can't just go back to the old days of having a giant Oracle database that you just keep throwing more bigger CPUs on or more CPU cores or bigger RAID arrays. You come to a limit where that just can't scale any further. And not only that, you're dealing with things like disk seek time. So even if you did have like some massive petabyte hard drive, you still have to wait for that disk head to move around, right? So there are still advantages to using a cluster of computers with many, many, many hard drives where they can all be seeking in parallel with all their independent disk heads. The other thing is you don't want a single point of failure. So that giant Oracle database, what happens when it goes down? Well, bad things. You have to deal with replication and all that nonsense. Hadoop handles that problem for you. So it can actually keep track of what's available on your cluster and fail over automatically to backup copies if need be. Processing times are also better. If you have an entire cluster, you have that many more CPUs at your disposal, and Hadoop offers a means of parallel processing that can take advantage of all those CPUs. So again, remember, horizontal scaling, like we do with a Hadoop cluster, is linear. If you need to handle more data or need to process it faster, just add more PCs to the mix, add more computers to your cluster, and it will be that much faster. And that's not the case with vertical scaling. You start to hit these limits, like for example with your disk seat times, where linear scaling is not possible when you're doing vertical scaling. Now, Hadoop originally was just made for batch processing, and the idea was, well, if you need to run some sort of analysis that you can wait a few minutes for the answer, Hadoop might be for you. And let's be honest, if you've ever dealt with a giant database on an Oracle instance in a data warehouse, those don't come back instantly either. That can take several minutes as well. So, we're not really doing any worse than we were back in the Oracle days, but there are things that have been built on top of Hadoop that actually do make it appropriate for interactive queries as well, and we'll talk about that as well. There are systems that can also expose the data from Hadoop in a means that can be consumed by web applications or whatever you want at very high transaction rates, so it's not just for batch processing anymore. So that's sort of the backstory of Hadoop, what it's all about, what it's for, what it's used for, why it exists, and why it's so powerful. So up next, let's talk about the actual technologies that make up the Hadoop ecosystem so you can talk about it and know just enough to be dangerous. See you in the next lecture.